Welcome to the learning program for the B38 and B48 petrol engines. In this learning program, you receive an overview of the new 3-cylinder B38 engine and 4-cylinder B48 engine. The explanations and images relate to the 3-cylinder petrol engine. Special features or differences to the 4-cylinder petrol engine are addressed separately. The new BMW engines will be introduced on the market from March 2014 in the F56. Hence why, in this learning program, the engines are described on the basis of the Mini models. The new engines will be introduced in the BMW models at a later stage. The technical descriptions, as well as the image views, are identical and can be transferred for later use of the engine in BMW vehicles. Similar to current engines, the engine identification is located on the crankcase. The 7-digit engine identification is almost identical to the 8-digit engine code. The two numbers differ only after the first 6 digits. Using the mouse, click on the numbers and letters of the engine designation and marking to learn more about the importance of this coding. The letter is a code for the engine developer. In this case, the letter B represents a BMW Group engine. This number specifies the number of cylinders. This number represents a petrol engine with Valvetronic direct fuel injection and turbocharging. The installation position is marked with these letters. An engine marked with the letter A is a petrol engine with transverse mounting. The two numbers provide information on the displacement of the engine in tenth of a litre steps. The B38 A15A engine has a displacement of 1.5 litres. This letter specifies the type test. The letter A represents standard. This letter indicates the performance class of the engines. Currently, the new engines are offered with the following performance classes. K means lowest performance class, U means lower performance class, M means middle performance class, O means upper performance class, and T means top performance class. The last number of the engine type provides information on the number of technical updates to the engine. 0 represents a new development. Updates have the consecutive numbers 1, 2, etc. The consecutive engine number is located above the engine identification. Here you see engine types used in the F56. Match the corresponding engine type to the vehicle types. Very good. That is all correct. The new B38 and B48 engines are based on the N20 engine and N55 engine. The BMW efficient dynamic strategy was consistently further developed for the new petrol engines with various measures. A 3-cylinder engine was built for the first time at BMW, which receives a coolant-cooled aluminium exhaust manifold in addition to a map-controlled vane-type oil pump for optimized consumption. In comparison to the N20 engine and the N55 engine, The B38 and B48 petrol engines pursue another strategy. Upon closer inspection, an increased number of common and synergy parts with the new B37 and B47 diesel engines becomes apparent. The objectives of the modular strategy are the reduction of costs, the increase of flexibility in production, and the increase of customer satisfaction. In general, 3- and 4-cylinder petrol engines, similar to the 3- and 4-cylinder diesel engines, are designed and manufactured according to the modular principle. A special feature is that the crankcase of the 3-cylinder petrol engine and the 3-cylinder diesel engine are made from the same raw part casting geometry, and the crankcases therefore do not differ before machining. The common parts used are components which are installed in the different engines in an unmodified form. They are shown in green on the graphic. Synergy parts are components which are identical in their function, but have been adapted to the various requirements of the engines. They are shown in yellow on the graphic. The engines with the same number of cylinders can have other common parts. Hover your mouse over the components to find out their designation. Familiarize yourself with the highlights of the two engines. Click on the component names to determine their location and click again on the highlighted component to obtain more information. The specified power of the alternator is adjusted via intelligent generator control. The coolant pump is driven mechanically. The oil filter module comprises the oil filter housing and an oil-to-water heat exchanger. Depending on the engine design, the oil-to-water heat exchanger has different dimensions. The direct fuel injection takes place via solenoid valve injectors, which are firmly secured to the rail. The valvetronic comprises a double vanos and the variable valve lift. The B38 engine uses a single-scroll exhaust turbocharger with an electrically adjustable wastegate valve. The B48 engine uses a twin-scroll exhaust turbocharger with an electrically adjustable wastegate valve. The oil supply takes place with help of a map-controlled vane-type compressor. The vacuum pump is integrated in the housing of the oil pump and connected directly to the drive shaft of the oil pump. It supplies various secondary consumers via several vacuum lines, such as the brake servo with vacuum. Due to design, during the combustion blow-by, gases travel from the cylinder into the crankcase. There they mix with the engine oil, which is present in the form of oil mist. In order to protect the crankcase against damage, the blow-by gases are discharged via the cylinder head cover. The crankcase ventilation is designed in two stages for the B38 and B48 engines. In charged mode, the blow-by gas is separated from the oil via a labyrinth oil separator and supplied again upstream from the exhaust turbocharger to the combustion process. If the engine is in a naturally aspirated operation, the blow-by gas cannot be introduced upstream of the exhaust turbocharger due to the lack of vacuum. Therefore, the blow-by gas is passed through the holes in the cylinder head cover directly to the intake ports. The positions of the various mounted parts are identical on both crankcases. The crankcases of the B38 engine and the B48 engine have a closed deck design, in comparison to the N20 engine, which has an open deck design. The three-cylinder engine has one counterbalance shaft, whereas in the four-cylinder engine, two counterbalance shafts are installed. The crankshaft of the B48 engine is manufactured in a forging process. It has a crank pin offset of 180 degrees. The drive of the counterbalance shafts is effected on the output end. The crankshaft of the B38 engine is also forged. Due to the number of cylinders, it has a crank pin offset of 120 degrees. The drive of the counterbalance shaft is performed differently than in the B48 engine, opposite the side delivering the power at the first cylinder. To reduce the fuel consumption, current BMW Group vehicles are equipped as standard with an automatic engine start-stop function. As a result of the more frequent starting operations in comparison to engines without an automatic engine start-stop function, the bearing shells are exposed to enormous stress. The oil pump no longer delivers oil when the engine is at a standstill. This is why the oil film between the bearing shell and the crankshaft cannot be maintained. As a result of the insufficient oil film, the crankshaft has solid contact with the upper bearing shell. If the engine is started again, friction occurs between the two components. Until the oil film is built up again, there may be increased wear of the bearing shells. This is why the upper bearing shells are covered with an IROX coating. It consists of polyamide, imide, a very hard plastic. It prevents wear of the bearing shells, reduces the friction, and thus increases the durability of the engine. Undesired oscillations and vibrations may occur in an engine due to the many movable components. In order to increase ride comfort, the disturbances must be eliminated. A four-cylinder engine is in principle an engine with very low oscillations, as the mass forces of the cylinders cancel each other out. However, the engine is not completely smooth running. The oscillations occurring in the four-cylinder engine are reduced with two counterbalance shafts running in the opposite direction, which rotate twice as fast as the crankshaft. If one takes a look at the crankshaft in the three-cylinder engine from the front, it becomes apparent that the forces which act at the crankshaft during engine operation cancel each other out by the crankpin offset of 120 degrees. No free mass forces occur. However, from the side it becomes apparent that the various forces acting on the crankshaft during engine operation do not cancel each other out. With the crankpin offset of 120 degrees, the forces point in different directions. As the free forces shown are connected via the crankshaft, so-called inertia torques occur. The engine may start to wobble. A counterbalance shaft is installed to offset this wobbling movement. It rotates in the opposite direction at the same speed as the crankshaft. With help of the counterweights, the counterbalance shaft generates a torque which counteracts the inertia torque at the crankshaft at the same intensity and frequency. With a correct setting of the counterbalance shaft to the crankshaft, the wobbling movements overlap in the opposite direction and almost cancel each other out. In the B38 engines and B48 engines, the familiar valvetronic is used. An exception here is the B38A12 engine, which has a double Vanos without valvetronic.